Okay, here we are again. Let's go through the steps again. The integral AU, and this is our rule. This is our rule. So let's see what we can do with our rule. Now notice I don't need this step anymore. Okay, well yes I do, but I don't have to calculate it. So let's see what I need for my rule. I need A. Well, A is 1 here. There's no number in front of any of these. U is 5x fourth plus 1. N is the power, that's 4. N plus 1. F of x is x third. Now du dx equals 20x third, that's B. So what I have to do is define dx as du over B, or du over 20x third. So now what I have to do is substitute u, n. I already have this in there. I don't have to substitute that at all. And these, in my formula here, A is 1. Okay, now here's my, well, let's finish this first, which what did I do? A is 1. U, this is the fourth. F of x is x third, that's there. Now dx becomes du over b, which is 20x third. Notice the x thirds cancel. So now I'm left with is u4 du over 20. I can put that in my rule now. A is 1, but I have a 20 here. So I'm going to put 20 outside, 1/20th. U, 4 plus 1 over 4 plus 1. And don't forget the c here. What I forgot here was the c. Okay, so this becomes 1 over 20. U is what? U is 5x plus 5x fourth plus 1 to the fifth over 5 plus c. So the answer becomes, well, 5 times 20 is 100. 1 over 100. 5x to the fourth plus 1 to the fifth plus c. And there's my answer. All right, now that shows you how to use a rule. Now we'll do a few more too. I just want to, I don't know how I got 200 there before, but I think I multiplied 5 times 20 and got 200, which is an interesting. Oh no, because before I had this as to the ninth. Okay, that makes me feel better. Let's do another one, and I'm going to put my rule over here like I do. Stick it right in the corner if I can fit it. So I have my chain rule. So I have dy equals the integral a u to the n fx dx. So y equals a u n plus 1 over n plus 1. Fx stays there, and dx becomes du over whatever b is. And we know that b plus c, oops, I'll go plus, let's do this a little bit tighter. Fx dx over b plus c, and we know that b equals du dx. All right, well that gives you a formula. It's a little bit more complex than a normal one, but unless you want to do steps, and it's tough to give you steps on a reference sheet. I tried that a few times. Nobody ever read the steps. So I took a step forward and developed a integration rule. Okay, let's take another example. Integral of 5x squared.
Is b du dx or dx du?
I'm sorry?
Is b du dx?
B is du dx.
Okay.
Yep. Yep. It's actually dx over du dx. I just didn't want to confuse them on that. I fooled around with this a whole number of times and figured out the best way. Because, okay, so, well, now we have a square root in here, so we know whenever we get roots, we have to change them to exponents. So let's alter this. We know that's going to be y. X third minus 4 to the 1/2 dx. Well, let's define our terms now. A is going to be 5. Got a 5 in front of those. U is going to be what's inside the parentheses raised to a power. Du dx equals 3x squared. That equals b. Okay? So we know that dx over b, which we need, is going to be, So we know that dx is going to be du over b, or du over 3x squared. So we need the dx, we need the u, we need the a, and we know that fx, which stays there, that always remains there, is 5x squared, and we know that n equals 1/2. Now that we have all this, we can substitute in this rule here. So y equals a, which is 5, u 1/2 plus 1 divided by 1/2 plus 1. F of x is simply x squared. And dx equals du over 3x squared. Oh, I forgot to substitute in again. I'm sorry, I'm skipping a step. Let me go back. I shouldn't be skipping this step.
This is du over b. Is that what's going on here?
That's du over b. I'm sorry.
That's what, okay.
All right, I'm sorry. This is du over b.
I knew something was not.
My fault.
Yep, okay.
Okay. When I rewrote it, I kept the
Yeah.
x. Okay, let's go into the integral. All right, we have 5. We keep x squared. U is now to the 1/2. And dx is going to be du over 3x squared. Let's cancel the x squared. So here's what I've done. Let's go back and start again. I started with the integral of 5x squared, the square root of x third minus 4 dx. I changed the square root to a power of 1/2. I looked at my chain rule and know I needed a, u, n, fx, and dx. So a is 5. U is what's under the parentheses. Du dx was 3x squared, what I call b. And dx is du over b, or du over 3x squared. F of x is always 5x squared. You're just maintaining it. And n is 1/2. Now we're going to substitute into the integral. So I got 5x squared, which stays there. 5a x squared, u 1/2. Okay, actually, in this case, a is x squared because I defined a as 5. So in this case, a is 5. F of x is x squared. This becomes 3x squared, the derivative. Du over b, which is that. Du over 3x squared. So I need this, and we're all ready to go, and these two. So this is going to be du over 3x squared Now the x squared is going to cancel. And we're going to do now, we'll do this again just to show you that this becomes 5/3 u to the 1/2 du. Now I can use the power rule. Now we use the power rule. So in that case, the power rule is going to be 5/3, which is A. With the power rule up there, A. And we'll change the power rule to a U. So we'll make it general. Okay? Well, let's make that general. That's a lot better. So it could be any value, not only x, it could be y, z, p. All right, so this is going to be u 1/2 plus 1 divided by 1/2 plus 1. Okay, the u goes out, plus c. Okay, so this is going to be 5/3. And let's bring the u back. 3x squared, x3 minus 4. 1/2 plus 2/2 is 3/2. 1 is 2/2. And this is 3/2 plus c. Now what do I do when I have 5/3? 5/3 divided by 3/2. Well, I keep the 5/3, that's in the numerator. And I take the reciprocal of the denominator. That's going to equal 10/9. Okay, so what do we get here? We get 10/9 x3 minus 4 to the 3/2 plus c, and we're in business. That's the solution.
2.5 minutes.
All right, everybody write that down. What I would advise is that you put this problem on a separate piece of paper and try to do it using this rule and see if you can get the answer I got. I'm going to give you one more, too. So we got 10/9 x3 minus 4 to the 3/2 plus c. That is what we call y. Okay? So y is equal to this. All right? And y is going to be equal to this. Sometimes we don't even bother about the y because we just look at the right side unless we have a practical problem. So now this is not an easy part of this course. So you have to do this very carefully, and I would say maybe rerun the video over again. I'm going to do another one. Same procedure. Because if you don't like my rule and you can figure out your own, very good. As long as you get the same answer I get. Okay.
So there's just 1 minute, so maybe you could just set up the problem.
I'm just going to set up the problem, and then we're going to go to our last 15 minutes of this lecture. Okay, so we want to get the integral of this. Notice we have two binomials now. How much time do we have left?
About 30 seconds.
Okay, so what do we have to do here? Well, if we look at this, in fact, what I'm going to do is overlay this, but I'll do this when we come back because I'm going to overlay this with the chain rule. Maybe that'll help you too. Okay? So while we disappear here for a few minutes, I'll be back for the last 15 minutes of this lecture. Unfortunately, we can only do it in 15-minute integrals. And that's why we're doing integration.